Just waiting on participant numbers for a few more seconds. Thank you. Welcome everyone. My name's Karen Blackmore. I'm an Associate Professor in the School of Information and Physical Sciences at the University of Newcastle. I'll be chairing this session on simulation technology and innovations in healthcare design. There will be a Q&A session at the end, so please leave your questions for our presenters in the Q&A box on the right of your screen. We will hear from two presenters today. The first presenter is Kimberly Ballinger from Statewide Trauma Clinical Network, Queensland Health and Clinical Skills Development Service. Thank you, Kimberly.
Good morning, everyone. Thank you to the Australasian Simulation Conference for the opportunity to present on behalf of the Queensland Trauma Education team. Thank you for having me, albeit virtually. I'm residing in Brisbane, and I guess this highlights the world that we're presently living in and the challenges that we're facing. And I guess this really emphasises the need to think differently when it comes to healthcare training. Today, I'd like to provide you with an insight into trauma care across Queensland. We'll explore the challenges that exist across the state when delivering trauma education and training, some of the background to the impetus of the QTE program development, and why this is different to the normal simulation-based education space. So a little bit of a background into trauma care in Queensland. So the traditional approach to trauma care is delivered to patients at the local hospital and health service level. So within Queensland, this involves 16 hospital and health services. And additionally, there's separate road and aeromedical retrieval services, who each have local policy and guidelines to lead care. Adding to the silos within the districts, silos exist within each facility, with often hierarchies dictating the care plan delivered. Understandably, this variation in practice leads to a variation in outcomes, and facilities with low incidence of trauma presentations often practice out-of-date and non-evidence-based care. So in 2006, the first review of the functional ability of the state to provide care in an organised manner to trauma victims was described in the Trauma White Paper Plan for Queensland. This plan aimed to provide strategic direction for the delivery and advancement of trauma services in Queensland. And from this, the Statewide Trauma Clinical Network was created. And with an alignment with the Healthcare Improvement Unit in 2015, there's been significant drive to provide a statewide collaborative approach to trauma care. The aim is for a focus on multidisciplinary and system-based healthcare services to ultimately address the gaps in trauma care delivery. To achieve this, education has been identified as a key priority area. It is important to understand that in the early days of trauma care, simulation-based education was viewed as important but not pivotal, but those tides are changing. So before a solution to the educational needs was developed, a data collection process was undertaken to understand the requirements of the state as a whole. It was understood that the ability, format, structure and timing of any education program would vary depending on the local site needs and staffing. The training needs analysis involved over 80 sites across Queensland, including rural, regional, remote, through to tertiary centres, and engaged a multidisciplinary team to identify the core components and requirements of frontline clinicians to develop, support and deliver trauma education. Importantly, this process did not just involve hospital clinicians, but understanding that trauma care starts at the roadside pre-hospital teams also provided insight into the educational opportunities in their particular environments. Recognising that various trauma training options already exist across Queensland, the program sought to enhance and expand on current resources available rather than to replace them, giving much of the stakeholder feedback describe the challenges with accessing these programs. So if we have a think about the traditional approach to trauma education, so most trauma courses are typically full day or longer than full day courses. They're usually a one-size-fits-all approach. They're delivered externally with a breadth of topics and content, and sometimes this content is not relevant to the individual and not always in the format that supports adult learning principles. So the engagement of any adult learner hinges on what's in it for me. So providing a contextualised, clinically relevant course boosts interest and ultimately provides better opportunities for translating learning into improved practice. Training may include procedural skills, didactic presentations, but not a lot is offered in the immersive scenario space. Importantly, when caring for trauma patients, the team is multidisciplinary. And so recognising this fact, any educational strategy should address this. For these reasons, Queensland Trauma Education helps solve the missing pieces that exist in the trauma education space. So the training needs analysis process identified a number of key themes recognised by local clinicians that would aid in a successful delivery of the program. So the themes identified that simulation-based education and multidisciplinary training were on the wish list for clinicians providing trauma care. There was also a strong focus on education that could be locally delivered by the team providing the same patient care learning together. Queensland Trauma Education is the result of the collaboration between the CSDS team, Jamison Trauma Institute and Statewide Trauma Clinical Network, and has created an educational platform to help address some of the issues identified. In particular, the flexibility to provide resources which are accessible, multidisciplinary, modular, and involve a range of learning platforms, including immersive scenarios, procedural skills, and role plays, were identified as important for the program's success. Importantly, the concept of having a centralised repository for a one-stop shop for all trauma education, clinical practice guidelines and courses was also essential to ensure clinicians have ease of access to clinically relevant trauma resources in one location. A dedicated website was created to solve this challenge. The simplicity for trauma educators is that all the hard work is already done. The content, supporting documents, debriefing guides, further reading across 8 trauma topics, it's all accessible and the implementation is straightforward. Additionally, the flexibility and scalable nature of these modular ready-made education resources is important to the end user, with the ability to build tailor-made contextualised education that is suited to the local area. The ability for clinicians in the local hospital to upskill in specific areas of need, such as the management of blunt chest trauma, with the ability to offer this locally addresses an opportunity to practice skills such as intercostal catheter insertion, and then consolidate the complex decision-making with patient management in an immersive scenario. So Queensland Trauma Education offers the whole simulation package experience. And I guess this can be likened to a food delivery bundle. So it's easily accessible. The ingredients are supplied individually and by themselves they're okay, but in combination they provide the recipe for a great meal. The ability to deliver this multifaceted education program locally means the requirement for travel is limited, providing security in educational programs in the current COVID climate. QTE resources are all developed by local trauma clinicians and so incorporate Queensland-specific standardised practice and evidence-based guidelines within the education resources across the variety of simulation-based formats making them relevant to the endgame of improving Queensland trauma care. QTE has also been introduced in a face-to-face format, using the existing educational resources to develop a multidisciplinary training course, trauma training course, where case-based discussions, procedural skills stations, and immersive scenarios were used to explore in depth the key assessment and management of important common trauma presentations. In this course, traumatic brain injury and chest trauma. Participants provided overwhelmingly positive feedback following the attendance of the course, emphasising the benefit of procedural skills training, immersive scenarios, and importantly, multidisciplinary team training. Additionally, each resource can be delivered as opportunistic training sessions, as well as combined for a participant-targeted course. The QTE program has been well received by trauma clinicians, with the data on the slide indicating an increase in the simulation education resource kit downloads and page visits since implementation in May this year. The ongoing Horizon plans within the program will see more educational resources uploaded to the website in 2022 and beyond. What began as a simple educational program to provide simulation-based resources has developed into an opportunity to create networking resources for the state of Queensland. The Queensland Trauma Education approach has seen the statewide trauma strategy morph into an inclusive collaborative effort with an emphasis on improving trauma systems and patient outcomes. With ongoing engagement and consultation with the QTE and STCN stakeholder groups, the QTE team will continue to develop simulation-based education resources for multidisciplinary clinicians. I'd like to thank you all again for the chance to showcase QTE and give you an insight into the accessibility and flexibility of the program. I'd like to acknowledge Dr. Frances Williamson, who is a Senior Staff Specialist at the Royal Brisbane and Women's Hospital Emergency Trauma Centre, for her tireless efforts as the QTE subject matter expert. And I'd also like to acknowledge the support of our key stakeholder groups, Statewide Trauma Clinical Network, Clinical Skills Development Service, Jamison Trauma Institute, and Clinical Excellence Queensland. Thank you again.
Thank you, Kimberly. That was a wonderful talk, and I thought an excellent overview of trauma care in Queensland. It's really useful, I think, as simulation experts to understand the different contexts where simulation's being used, and it was a fantastic oversight of just the practice of trauma care within Queensland from my perspective. I thought you also gave some really wonderful insights into the use of the different technology platforms to deliver simulation, and so thank you very much for that. So we'll now move on to our next speaker, and I'd like to welcome Robert Brownie from Insight Acumen. Thank you, Robert.
Thank you very much. All right, good morning, everybody. My name is Robert Brownie. This morning, we're going to cover the modelling team, background to this project, innovation and the role of simulation, problem and aims, the KPIs, data method and verification validation, the model, I'll give you a bit of a demonstration, results and conclusions. First of all, to the modelling team. We had Mr. Evram Kilic, Dr. Peter O'Neill, and yours truly, Rob Brownie from Insight Acumen. The background to the project. The design challenge for a new hospital is huge. there are a large number of units, services, resources, pathways, timings, schedules, delays, interconnections, as identified by the complex diagram on the left-hand side. But what about future technologies and their impacts? And what is the future demand? Our role is to support moving from the planned system on the left to an effective and efficient operation on the right-hand side. That's where our role is. In moving from the current to the future state, how often is policy changed based on pilot programs and evaluation? Pilot programs that once in action may have unforeseen consequences or that might take multiple years to understand the impacts. Ideally, improve efficiency and productivity via value-based care. So what changes can be made to provide better outcomes and improved cost per service? Ideally, have tools to assist health, make better informed decisions, have roadmaps that allow health to deliver better value for clients and patients and visualize the impact of those changes. Support stakeholders with a shared commitment to improvement, being able to future-proof these changes or improvements. So in the context of these immense challenges and complexity, let's discuss innovation and the role for simulation in healthcare. In the real world, in the bottom part of this slide, what is the best way to introduce a solution to a problem? To move directly to a solution can be very risky for time, schedule, and resources. So before investing those time and resources, it makes sense, in the top part of the slide here, to mitigate the risks by using modeling and simulation. So simulation allows this to take place, and this is our forte. So the identified problem and our project aim specifically, we were to test the design of a new hospital to establish future design. For data, we had current demand for model validation and forecast demand in 31-32 and 2036-37. We were to build and test the model against future KPIs and test the future performance via various scenarios. To the KPIs. The KPIs were provided by subject matter experts from within the current system, with emphasis on resource demand measured by utilisation and waiting time. To data method V&V. To summarise the methodology, which is somewhat generic for projects, gather required data, engage closely with stakeholders, map the process, establish interdependencies, determine assumptions and constraints, build the model, conduct V&V, review to establish the model is fit for purpose, and once that is done, forecast the future with reasonable confidence. So here's how that process looks, with modelling and simulation playing a central role in the blue area to reduce the risk of future failure. To data. We used 3+ years of historical data for model validation. We used forecast demand in 31-32 and 36-37, and this future demand information was provided from departmental level data. Now let's have a look at the imaging system process flow logic. Okay, this is how it could map out on a whiteboard, for example. At the lower part of this picture here, we have women, we have pediatric, and we have inpatient demand flowing into a system of holding. We have waiting areas to the left and to the top here. In the top area, we also have outpatients and external demand into reception and into wait areas. And after the waiting, into these specific services in these areas here. So that's kind of the high level look at this. In yellow, we have current base case resources. In pink, we have entries, exits, and processes. And in blue, proposed scenario testing. So key points from this, the current state is orange plus pink, and future is orange plus pink plus blue. To the tech we used Extend Sim software to develop a model. For the durations modeled for current state, we used 3 years of historical data. For future state, we used 10 stacked single year variations run randomly with a warm-up period of 1 year. Then we averaged the key metrics. The entire data set was approximately 600,000 future arrivals over 10 years, and run duration was approximately 30 minutes. All right, quick look at Extensim now. For those of you who haven't seen Extensim before, here is a quick look. Going to try to kick this video off here. All right, for those of you who haven't seen it before, it looks a bit like electronic Lego for serious modelers. We have libraries on the right-hand side. You're looking at an item library on the right-hand side there, and a bunch of these blocks brought out onto the canvas and connected in appropriate ways until the system that you're modeling is fit for purpose. So you see items moving through this particular model. We are setting attributes in this particular area here. As they flow through, we're able to split. In this particular split is a 50-50. Downstream, we have delays, and we have further splits. We have merge points that I'm showing there in actually just being highlighted there. We have further delays in those two pathways into a merge point, another diverge point, which is a 40-60 split. We can settle those or make that even more complex logic. And what we're going to do now is turn animation off so that it runs much faster. And the measurement here in this general demo model was just to determine the output of the system. So it had a mean of 2016 exits with a standard deviation of 56. So a very general, just model demonstration there to Extensim. All right, here's part of the canvas of the imaging model in Extensim from left to right. You can see we have arrivals area for pediatric women's inpatients and outpatients and external, to reception, to waiting area and a holding bay, and pretty much around the outside here we have these services. So representation of the system there. Towards the top, users can also select a particular data set by a drop-down menu to run through the model. So now for a quick demo of the model itself. So this is the imaging department demonstration model. I've fast forwarded this model to 50,000 minutes, which is indicated just down the lower left-hand side there. We have the creation area of patients entering the model on the left-hand side. And we have the pediatric, women's, inpatients, outpatients and external entries, interpatient arrival, reception, then into waiting, then into services. So let's have a quick look at pediatric emergency. In this particular area, we're assigning a delay for this exam, and we're able to assign this randomly. So you can see that figure changing as patients come through that particular area. In arrival, we are able to set just one item in this activity, and that particular activity is set to random time as well. Crossing out of this one and opening up the reception area. The reception area has a resource, the receptionist. So what I'm clicking on now is the queue for that particular resource. Once we gain it, we can consume it in that activity and then release it in that resource pool release area. More information about this particular resource pool is just cloned out below. Total resources, those in use, those still available, and utilization of approximately 10%. Crossing out of that, just going to scroll down. You will have seen something similar in PowerPoint a minute ago. This is how it is represented on the canvas. So just different representation of the model, just with cloned values, just showing more information about arrivals and about resources and demand utilization. So just a different view that you can achieve. I'll scroll down. These are some of the charts of utilization for some of the resources. And I'm just going to turn animation off. So this will run much, much faster, and you can see those utilization charts build to the right over time. Now let's have a look at the results of the project. The model sought to outline the current state for the imaging department. So we operated with existing hospital records to set up the patient flow. We received information on the FTE and number of machines assigned to each modality. Number of machines are indicated in the parentheses here for the different modalities. We ran the model for 3 years and calculated utilization. You'll notice on the left-hand side here, 162%. So in the model, the MRI was allowed to operate beyond normal business hours. So that high utilization for the MRI meant that, the utilization means the MRI was used for large periods of time outside normal business hours. So the normal business hours are the denominator in utilization calculations. So assessed as fit for purpose by the SMEs, we moved on to future state. So this is a future base case. This sought to model 3132 data in blue and 3637 in green. From the previous process flow map, the future base is shown here in the inset box by the pink, orange and blue sections. So pretty much everything there. We conferred with the imaging functional group to set the number of machines for the future state, once again in parentheses. And we implemented processing times based on historical data and made the patients flow accordingly. So this is a summary table of the utilization results. We have modalities in the first column, number of machines, then utilization in 2031-32, 36-37, and then the difference between those two time periods. They all increased due to the high demand at 36-37, with the exception of the bone density modality. So let's check now the results of 3 scenario tests now that we've got the future base case sorted. So first is the maternal fetal medicine. This was one of the scenarios the imaging functional group wanted us to test because the MFM demand usually puts pressure on women's ultrasound. We modeled a decentralized machine and let MFM patients flow through a different version of the model, allowing specific focus on MFM. We tested the decentralized MFM scenario for both 3132 and 3637. And for this instance, we used one decentralized machine. The utilization figures we achieved in these 2 years, well above 100%, justify decentralizing an MFM ultrasound in the future state. Next, to the pediatric emergency department. This particular demand can be unpredictable and place extra demand on the imaging department. Through our discussions, we pinpointed that X-ray machines were a resource in high demand. So we tested the possibility of a dedicated X-ray machine for pediatric emergency. Both samples, 3132 in blue, 3637 in the yellow color, showed that a new decentralized resource for X-ray would be well utilized, but demand was not significant. And with only a slight improvement in average processing time, 21 minutes compared with 24 for current state, there was no clear justification to have an additional X-ray machine in pediatric emergency. The final scenario to present is MRI. According to the current state of the hospital, the imaging department only uses one MRI machine. We saw in an earlier slide a very high utilization of 162% for the single current MRI machine. Now testing of future samples, 3132 and 3637, showed that a system was even further stressed by the high demand in those years. So since utilization and average processing time figures were high with a single machine, we modeled the future scenario with an extra MRI machine. Here's 3132 and 3637 with the extra machine. So 2 machines were observed to reduce the pressure on the system with the improved patient experience, with the average processing time cut in half. So in conclusion, a decentralized provision of ultrasound services is viable for maternal fetal medicine. A centralized X-ray service is recommended for pediatric emergency to keep waiting times reasonable. And at least 2 MRI machines are required in the future system. So just a bit more on ED. Our main focus in ED was on X-ray, not on ultrasound, computerized tomography, or positron emission tomography. We were not asked to investigate lift reconfiguration, porterage, or space and tech reconfiguration. However, these factors would likely count against any potential business case for decentralization. Opportunities. Opportunities for simulation in healthcare: improve inputs for other models, inform new designs, reduce risks to testing changes, and reduce risks to operational outcomes. A call to action: SIM provides an efficient and cost-effective method for testing possible futures, a better understanding of health systems, and allows lower risk for testing possible futures and increased agility to undertake further testing. This is what we just covered. And here is some contact information for you. Thanks very much for your time.
Wonderful. Thank you very much for that talk and presentation, Robert. As a computer scientist, I think I particularly appreciated your complex diagrams. And I thought the talk overall really did give some really excellent insight into those really practical uses of simulation to guide and drive decision making. So thank you very much. So I noticed we have one question already in the Q&A. The box should be there on your right, and I would encourage all of those listening and watching with us here just to pop some questions in, both for Kimberly and to Robert. And I might actually just take the first question back for Kimberly while just to give you a chance to pop some more questions into that Q&A. So Kimberly, the question I had was, I was particularly interested that you mentioned, just one moment, sorry, getting phone calls, that I particularly noticed that you mentioned that one of the issues that you had within trauma care within Queensland was the disparate practice. And so part of introducing simulation, I'm assuming, was to deal with that. But obviously there's different kinds of simulations and different platforms. And I'd be keen to hear from you what you thought had been the biggest impact on standardization through the implementation of simulation.
In the context of Queensland Trauma Education, I guess, so unfortunately, I guess trauma care across Queensland historically has been quite fractured in that it is quite a siloed system. And so I guess there's no real overarching governance for standardising that care up until quite recently. And there's been quite significant drive for, I guess, creating clinical practice guidelines at the statewide level so that
Hi, Cam. Your audio just faded out.
Is that better? Can you hear me?
Still not as good as earlier.
Try again, Kim.
Better there now?
Yes, we've got you back.
Okay. So yeah, I think there's been there's now quite a significant drive to try and create clinical practice guidelines at the statewide level so that then informs care delivery across the state. I guess with regards to what we're trying to achieve with standardising the education with the simulation focus is that we're incorporating those kind of key evidence-based practice guidelines within the education resources themselves. Recently, Queensland introduced a blunt chest guideline, which is quite significant because it's sort of the first of its kind in Queensland, which when I tell people that, it amazes them that there isn't that consistency and standardisation. So we've incorporated that guideline within all of our resources that we've made to then, then that's going to further, I guess, impact that standardised care and that really excellent trauma care delivery, I guess, on the front line.
Fantastic. Thank you, Kimberly. So I do have a question in the Q&A for Robert, so I might just go to that question now. So Robert, the question comes from Marcus, and he asks, are there any clinical skills modelled that influence patient flow?
G'day, Marcus, thanks for the question. I think the answer to that would be no, none specifically for this particular model. So that was beyond the scope of this particular model.
Wonderful. And again, everybody, I just encourage you, pop your questions in the Q&A. So I might just pop in with another question as well, this one for you, Robert. So one thing I noticed, and I've encountered this having done some work previously, particularly with 2D simulations to drive decision making, was how did you notice any issues there with respect to communicating the mechanics of the model and the outcomes of the model to lay people using the 2D approach? Do you think there is a role there for 3D animations of those complex simulations?
That's a good question. There was a big challenge in particularly engagement by subject matter experts and SMEs such as clinicians having sufficient time to participate as stakeholders in the process. So on the one hand, absolutely required because it is their current system and their future system. But for them to have the time to be engaged was a challenge, and it was also a challenge in relation to the data in that they understood that there were issues, but attempting to quantify objectively what the number was of that issue was super challenging, as was quality of data is quite a challenge. On the 2D versus 3D front, we worked hard to keep the stakeholders engaged on 2D. I think if we had gone to look at those porterage issues or the lift issues and the tech and space issues, there might have been the case then to move to 3D potentially. But in this particular tool, then 3D is a significant time impact and would therefore have a serious cost element attached to moving from 2D to the way more complex 3D in the tool.
Yeah, I completely appreciate that. I delivered a similar outcome using student projects from my software engineering for a local organisation that engages in similar kinds of simulations. So yes, I am aware of the time and cost impacts of those different approaches. So I've just got another comment come in from Kelly into the Q&A, which was just, she mentioned she was interested in cost, and thanks for sharing. So perhaps that might be another interesting thing that from the perspective, either if you could just pop in and if you've got any comments around in terms of how you see the value of the use of simulation in both of these two use cases in delivering some kind of return on investment.
I'm happy to go in first, Kim, if you're happy with that. Okay, no worries at all. I guess the general rule that I use when I'm talking to people that who might wish to engage my services is spend $1,000 to save $1 million down the track, and de-risk in the software, which is very, very low risk, and don't make that mistake down the track by just going directly to that solution, which may be risky, which maybe we could have de-risked earlier. So I think there is absolutely a case to have simulation used more to model the systems. It's not world sim. It's not going to model everything that is needed for a future system, but in terms of process flows and resources and utilization and trying to work out what can fit with those KPIs, then this particular tool is excellent for mitigating those potential risks in the future.
Thank you, Robert.
I probably am going to use a bit of a cliche here, but I guess cost in the context of trauma is quite significant in that, you know, there's patients on the other end of this. So our intention, I guess, primarily is to try and improve that patient care on the front line by informing clinicians of best practice and using simulation, I guess, to address those technical components, but really, like we all sort of know, that non-technical component of healthcare that is so critical in managing those crisis situations. So cost-wise, I think we know that, I guess, poor impacts on patients is a huge cost to healthcare organisations. And I guess that's why it was education was identified as a key pillar within the strategic direction of trauma care across Queensland. Because if we can try and address those gaps in clinician practice and
Kimberly, do you just want to flick your microphone again? Sorry.
it knows too well that it just shouldn't be listening to my voice, really, I guess, or relaying it. So yeah, I think if we can address those gaps in knowledge, skills, behaviour, and try and improve that care, it's going to be an enormous reduction in cost, and I guess cliched cost toward, you know, the patient themselves. So all in all, hopefully, and you know, this is a program very much in its infancy, but our hope is that through some pretty rigorous evaluations that we'll be able to establish that this is attributing to great improvements in that trauma care delivery.
Wonderful. Thanks, Kimberly. And I'd argue that there's nothing cliche about that at all. Even the most technical of us in the most engineering focused applications of simulation are ultimately impacting society and our social worlds around us in everything we do. And so I think we should even always have a view to the social impacts of everything we do and factor that into how we understand cost. So I don't actually have any more questions come into the chat. We're very close to finishing time. So on behalf of everyone who's listening and behalf of the conference organisers, I'd like to thank you both for presenting and sharing your work and your insights with us. And this session now is ending, and we're about to go into a break period within the conference program until 1 p.m. Australian Eastern Daylight Time. So please join us for student presentations in track 1 or the masterclass 2 with Stephen Guinea, Elizabeth Lee and Jay Wabala for those who have registered. Thank you, everyone.